Welcome to Applications of Derivatives, Lesson 2, Differentiability and Continuity. There you go, an octosyllabic word and a pentasyllabic word. Alright, differentiability talks about where functions are differentiable. Continuity, where functions are continuous. In order for us to talk about differentiability and continuity, let's go ahead and look at the following statements. Go ahead and read those and pause this, and then we'll move on. Okay. Differentiability and continuity. First, we're going to find out if f of x is discontinuous anywhere. So we have to evaluate sine of 0. Sine of 0 is 0. Okay, now we have to figure out this piecewise function. Let's try the 0 end first. 0 cubed, 0. Okay, that means that at 0 it's continuous. Now about at 1, what is 1 cubed? It's 1. Alright, now we're going to go ahead and figure out what the third part is at 1. 7 times 1 is 7, minus 6 is 1. So it is still continuous. And now we'll figure it out at 4. 7 times 4 is 28, minus 6. 22. Now we're going to figure out at 4. 4 squared, 16 plus 17, plus 7, 23. Okay. So, f of x is discontinuous It would help if I could spell it right. Discontinuous and non-differentiable at x equals 4. If it was continuous, these two numbers would be the same. They're not. Alright, now let's find out what f prime is. Alright, what is the derivative of sine x? What is the derivative of x cubed? What is the derivative of 7x minus 6? And what is the derivative of x squared plus 7? Okay, so the derivatives are here, cosine 3x squared, 7, and 2x. So what is the limit as cosine of x approaches 0? 1. That is correct. What is the limit as 3x squared as x approaches 0? 0. Okay, there is a non-differential point because the limit doesn't exist for the derivatives. Okay, as 3x squared, what is the value of 3x squared as x approaches 1? 3. What is the value of 7 as x approaches 1? 7. What is the value of 7 as x approaches 4? 7. Hey, wait a minute. We already know that it's non-differentiable here. We didn't need to check that. But we're going to see that it's non-differentiable at x equals 0. In order for it to be differentiable, these two limits have to be the same. And then it's also non-differentiable here at 1 because these limits need to be the same in order for it to be differentiable. So we also have to write f of x is also non-differentiable. Thanks for the writing. At x equals 0 and 1. So f prime is non-differentiable at 3 different spots. First of all, where it was discontinuous up here at 4, and also where it was non-differentiable because the limits did not exist. Alright, f of x is defined as the absolute value of x plus 3. F prime of x, it's a piecewise function, okay, is -1 for x less than -3, and it's +1 for x greater than or equal to -3. Alright, so it's obvious to see that f is continuous. There's no break in the graph, but it is non-differentiable. F of x is non-differentiable at x equals -3, because the limit of the slopes, or the slopes, change. So this is called a cusp here, a nice pointy end, or a point that the derivative graph, no, sorry, not the derivative graph, the graph of f of x has. At these pointy spots, it's called a cusp. The function will be non-differentiable at that point. Alright, let's move on, please. Alright, here we have g of x defined. It's a piecewise function. Let's first of all see where it is discontinuous and non-differentiable. So let's go ahead and evaluate these. Cosine of x as x approaches 0. Cosine of 0, 1. Cosine, 2x evaluated as x gets close to 0, 0. Value of 2x as x approaches 1, 2. The value of x squared as x approaches 1, 1. The value of x squared as x approaches 5, 25. And the value of 8x minus 15 as x approaches 5, 25. So g of x is discontinuous and non-differentiable at x equals 0 and 1. Now let's see if g of x has other discontinuities looking at the limits of the derivative. So let's see here, g prime of x, that equals negative sine x for x less than 0. It is 2 for x being between 0 and 1. It is 2x for x being between 1 and 5. And it is 8 where x is greater than or equal to 5. So we already know at 0 there's a discontinuity. We already know at 1 there's a discontinuity. So all we need to do is check the limits at 5. So let's see here. What is the limit as x what's the value of 2x as x approaches 5? 10. What is the value of 8 as x approaches 5? 8. So g of x is discontinuous and non-differentiable at x equals 0. Sorry, x equals 0 and 1. G of x is also non-differentiable at x equals 5. And that's how you'll be doing your homework, telling me where it's discontinuous and non-differentiable, and then finding out where it also could possibly be non-differentiable. This ends lesson 2, applications of derivatives, differentiability, and continuity.